Hello students, welcome to today's lesson where we are going to discuss something about the quadratic equations themselves as we did last time. But today we are shifting our mind to quadratic formula. In the last video, we discussed on how we can derive the quadratic formula from the, that's a form of the quadratic equation, which is ax squared plus bx plus c is equal to 0. Right, based on what we discussed, you bear with me that the formula which we produced is a formula which is in the form of x equal to negative b plus minus b squared minus 4ac divided by 2a. This is the formula which is derived from the form of the quadratic equation. So this is the kind of formula that you can use to solve all quadratic equations of this kind. Apart from the two methods that we have discussed, that's the completing of the square and the factor method. So now let's get into business. Here I have an example where we will need to use the quadratic formula in order to come up with the solutions of that particular equation. Solve the equation. Uh, 2x squared plus 7x is equal to 15. Right, here there are some restrictions. It's not that you have got that freedom to use any method. Today we are literally there just going to discuss on how best we can apply the method of the formula. Right, so here we go. Right, so based on what we discussed at that time in the previous video, you should be in the position by the formula itself to state the meaning or say the values which are represented by A, B, C in a particular equation. Because in this case, each time we're going to use the formula, you should be able to understand that the formula contains these letters. And these letters represents what? The constants. And these constants are light attached in the what? Terms of the equation itself. So for example, as I have displayed it on the board here, we have an example here, which is 2x squared plus 7x is equal to 15. Now, before I take down the issues about the value representing A, B, and C, what we need to do always is first of all, trying to make that equation to be in the form of ax squared plus bx plus c is equal to 0. So which I mean to say here is that like each time you are given an equation, when you would like to use the quadratic formula, first of all, this equation must be equated to 0 because that is the form of the quadratic equation. So as you can see, this one is equated to 15. So what I'll do here, I'm going to transfer this 15 to the left-hand side. So that what I'll have next, it'll be 2x squared plus 7x. When this comes here, it'll be negative 15, and this equal to 0. Right, so as you can see here, this is a real design of a quadratic equation. Neither this is the form of the quadratic equation. Now, in this equation, you will now be able, first of all, to come up with the formula itself so that it can match this particular equation. So now when I'm using that formula, now it will be like in this equation, there's a variable x, which means my formula will be able to be to solve the value of x. As such, I'll write here x is equal to that particular formula that we formed. If the equation had maybe a variable y, here you don't always write x, but now you talk of y is equal to a, b, c, d. And if maybe the equation has got a variable, maybe m, you go by that. So here x is used because the equation has got a variable x. So now the formula which produced, if I need to find the value of x, it go like x is equal to that formula of the quadratic equation, b minus or plus or minus square root of b squared plus, not plus, but now minus 4ac, that one should be divided by 2a. And we are all aware how this formula is coming about. We all were there in the previous video when I was explaining of it, how this one comes about. So that's how it goes. So now, each time I would need to find the value of x, I need to be able to at least consider the letters in this formula, which are B, C, and A. In the format of the equation, we already discussed that the A, B, and C represent the constant of a particular equation. So what I'll do here, I need at least to come up with the representation of A and B, A, B, and C in that equation. So those ones will come right away from the equation we have up here. Right. So if we can at least marry up what we have up there, we'll be able to deduce that the value of A in this equation should be the coefficient of x squared. And in this case, it will be 2. And after, you need also to give us the representation of a letter which is a C, a constant C. So if you go by what we discussed at that time, you'll be able to see that C is represented by a constant number, which is negative 15. The same applies to a B. The B will also be the coefficient of a term which is non-quadratic. In this case, we're talking of the term which has got a variable x. In this case, we're talking of 7x. Here now we'll talk of a B being represented by value 7. So here it means our B is equal to 7, and that of a C is equal to, that is negative 15. Right. So I think there you cannot get lost, because that's what we studied up if with in the previous videos when we are introducing the quadratic equation. Say what is A, what is B, what is C. So it is by that. So all these values here are coming from the equation which you have up there, only if that equation is equated to 0. But if it is not equated to 0, then it means the values of A and B cannot be found. So it's always when that equation in that form of the equal to 0. Right. Now, having known the value of A as 2, B as 7, C as negative 15, what is next? So here, you bring your formula down here and then go for the substitution. So here it'd be like x is equal to, fine, here's negative according to the formula. It means I'll write down my negative as such. But where there's a B here, a B is represented by a constant, which is a 7. So it means I'll substitute for B here. Instead of having a B in the formula, now I'll write a 7 like this. But the rest of the story will go like that, positive and negative. That ensures that the square of a number should always be in two folds. It can be negative and positive. Then now I'll go into the roots, where my root comes in. We've termed like B squared. So where there's B, I'll still more substitute for 7. So now it will be 7 squared in place of B squared. Then I go for the negative. That's negative 4 multiplied by A. So here my A is 2, and then multiplied by negative 15. That is the value of a C. Denominator of which is 2A. So in this case, it will be 2 times 2. That's what we get up there. Right. So once we have done this, students, I think at that particular instance, you find the rest of stories just about the calculations using a calculator. It's just a simplification. Right. So here we go. We have a situation which goes like, here's a negative 7, then here plus, minus, and you go on there in the root. You have 7 squared. You get that one as 49. Then here it'd be like negative 7, sorry, negative 4 multiplied by 2 multiplied by, that's a negative 15. So the answer of which you get there, it'll be positive 100 and what? 20. That's what you have it there. Now, down here, the denominator, what do you get? It's a 2 multiplied by 2. So this one gives us a 4. So you keep on simplifying, using calculator where necessary. It goes like that. So what you have now, x here, it's negative 7. You leave it as such first, then plus, minus, and you get inside where you always see that you have got 49 plus 120. And that one gives us 169. That's how it goes. So down here, still more, the whole of that expression still have to be divided by a 4. Look at that. You still have to go on. You see somewhere here, it's easy for you to take the square root of a number inside the root, which is 169. So if you can at least try to take the square root of the 169, the answer of which you get there, it will be 13. So here you still more go on and simplifying that way, but don't skip one of those signs. Both signs has to be written down. So here it means take the square root of 169 that tells us the square root of 169 can be a positive 13 or a negative 13. Right. So down here, you still have what? A 4. That's the way it goes. So the only thing that is needed here is just a matter of knowing the value of A, B, and C. You substitute, the rest of story is just a matter of the simplification. If you opt to use the calculator, just keep on calculating like that. So let's finish this one down, up. So from this stage, we have got this x is negative 7 plus or minus 13. So what we do with these two signs, we split them. We light each one of them one at a time. So it'd be like negative 7, we begin with plus, you light plus there, 13 over 4. Right. Then after you light all, now you're going to consider the negative. To say negative 7, negative 13. This one should be divided by a 4, like that. So please understand why we have handled the two sides in the middle here. So this is the way it goes. You light one for positive and the other one for negative. So it's split like this. So once that one has been done, is when now you go on and simplify each one of them separately, which is obvious that you are going to get two values of x, just like it was in the previous methods where you were solving quadratic equation, you were able to come up with two values of a particular variable. Right. So now let's see what we're going to get from here. Right. For the first one, where we've got x equal to negative 7 plus 13 over 4, it means you're first going to simplify the top numbers. Negative 7 plus 13, that one gives you number 6. So which will now be 6 divided by 4. So it's still more light there, all like that. Then here, negative 7, negative 13, that obviously is going to give you negative 20. And that negative 20 has to be divided by 4. So it looks something like this here, that. So like that, x is equal to 6 over 4, and somewhere there is equal to negative 20 over 4. So if you can simplify, this one gives you x is equal to 3 over 2, or here you get negative 5. So here again, you are free to leave this one in a decimal number, which can be 1.0, that is what? A 5. Or leave it like 1 over 2 in whatever form. It means the same thing. So let's please factorize this one in a proper fraction, which is written like 3 over 2. Then that one is all negative 5. So by this, it means we have solved the quadratic equation. Right. So which means if we had solved this equation, or the answer, which are also defined as roots in our discussion about the equation, are 3 over 2 or negative 5. Right. So that's the way we do in solving quadratic equations by use of formula. It's just a matter of substitution. Right. Maybe on one way or another, you might also be interested to find out, is it really true that these are the roots of that equation which you have just solved? Are really this one the roots of the equation which we have just solved, which is this one here? We are solving this equation, which is 2x squared plus 7x is equal to 15. Are really this one the roots? So what we're saying, really, for you to find out that these are the roots, it means you can really be able to use them. This is what you have found, that is 3 over 2 or negative 5 to come up with what? The equation itself. So let's see how best we can produce the quadratic equation from these given roots. Meaning to say, if these are the answers after solving, can I use them to come back to the original equation? So the answer here is yes. So let's just discuss a little bit and see which would be regarded just like a proof to the solution as such. Right. So I will do this. I will write that one just like another example, which would just like a backward solving of which. Right. So number 2, let's have like given the roots 3 over 2. That's a only negative 5. Find the quadratic equation. Right. Find the quadratic equation whose roots are 3 over 2 and the -5. You might have sometimes that type of questions coming. Right. So what we do in order to come up with the equation, whose roots are this and this, is simple. This is what we do. Look here. Right. The method we use comes from the first method of solving quadratic equation. That is by factor method, where we could find ourselves factorizing a particular quadratic expression of a quadratic equation. So it'd be just like a reverse of the steps. I am at the baseline, at the end, where we have got these answers. So it's just like have now to go the process backwards until up the top. So it's just like when you are factorizing, now we are going to multiply, things like that. Right, so let's look at this. We are given roots as the 3 over 2, or also I'll take it as and -5. So what do we do here? We may be able to write just like a reverse process. These are just solutions which are coming from solving quadratic equation. So there were steps which were going downwards, equating to 0, and then you go talk of factorization. Then at the end, you talk of brackets, each bracket equated to 0, things like that, and then find the roots. So here what you do, when you have got this and this, it means our equations which we are solving can be in any of the variables. So let's take that this equation has got a variable x. So this means our x has a value which is 3 over 2 or a -5. So that's what it means there. It can be y, it can be what, but let's now choose that equation we were looking for has got a variable x. So it'd be just like what was happening then for us to have this one and for us to have got this one. So it was more like, in this case, it is just like x was equal to 3 over 2 or x is equal to -5. As such, this meant that the moment this one is here, it means we are solving from the system whereby this was first of all on this side, and this 5 again was first of all toward that side. It's when I would deduce that x is equal to 5. It means this 5 will transfer from here to that side. So you go backwards like x, when this comes here now, it will be -3 over 2, and here it will also be x, -5 is equal to what? Is equal to 0, and here you get a 0 again. Right, because you transfer this one to the left-hand side, the result what you have here is 0, and here you have x minus 3 over 2 is equal to 0, or you also have here like x minus 5 is equal to 0, so which means in this case you have got what is, let's say x minus 5 will be equal to 0 in this case, after you have transferred this 5 to the left-hand side. Right, sorry, for this part here, it should be x is equal to -5, not a positive. So when you are transferring this side, that one should now turn out to be a 5, like that. See here, it is a -5, which we have found, only that I have to overlook here, but now it should be -5 we're waking up with. So it's just like a reverse process of some kind. So it means when these roots were found, it was first of all 2 expressions which were equated to 0, each one of them. So now, it'd be like now, this one, we're coming from what stage? So obviously, if you can remember the first process of solving quadratic equation by factor method, it means that these 2 expressions on the left-hand side of these 2 linear equations were just like the ones which were multiplying. But now, before that, for this one here, since we have got a fraction here, you can first of all treat that fraction out before you take the stage that we're going to have it here. So to treat this fraction, you can multiply every term by denominator, which is a 2. So to multiply that one, you get a 2x. Then multiply by this one, you get a 3. And here you get a 0. So you have got a normal one here, x plus 5 is equal to 0. So this, if you follow those stages, it meant that we had 2x minus the 3 multiplied by x plus a 5, which is a 0. Try just to follow those stages, how we are solving quadratic equations by the use of the factor method. You find that it was just like this, coming to that, then to that, and then it goes on like that until you have got the solutions. So now, to come with that, what we call it, the equation itself from this stage is simply just a matter of what? Expanding, clearing out the brackets, So it'll be like you take this one multiplied by the terms in the next, this one multiplied by the term in the next. Right, that's what we'll have in here. Right, now let's see what we get in this one then. So it'd be like 2x multiplied by x, we get 2x squared, then 2x times this one, we get that is positive 10x, and minus 3 times x, we get negative 3x, and then we go minus 3 times 5, we get negative 15, and this one is equal to 0. Now, let's deal with the like terms. Here we have 2x squared. Now 10x minus 3x, that gives us what? Positive 7x. And here we are remaining with the negative 15 is equal to 0. But now, if we are to leave it the form the way it was when we were using quadratic formula to solve that equation, this is the equation we want, but this 15 was in this side, you can still more transfer this 15 to the right-hand side. So it means the equation which you had originally, it will come as 2x squared plus 7x is equal to 15. As you can see here, it is the same equation which we were solving in that case. So which means this process is really reversible, right? So by this, we can be able to understand that, say, this is the way we solve the quadratic equation. And then, more importantly, students see, this is the last of the method used to solve the quadratic equation. We started with the factor method, second root of the completing of the square. Now we had to discuss something about quadratic formula. Thank you very much for that. In the next video, we are just going to practice some practical questions of which you need to apply in the lab situations. Thank you very much.